All right, so I was showing you guys how to complete a square, right, to solve quadratic equations. My first period student asking me questions like, do we have to do the completing square? Or what if I have a slightly different way of writing it out, even though I was completing the square, but it doesn't look like the way you did it. Would there be a problem for the test or quiz? Now, for the quiz, do you guys realize if it's just multiple choices, you just have to tell me the right answer, right? So I don't care how you get it, except for, as long as it's not from AI or like Google, right? That's why I'm trying to push the lockdown problem, right? But if you have a way to either guess or figure it out using TI-84, yes, you do have access to TI-84 in a quiz, and also multiple choices, right? All I care is you get the right answer within very limited amount of time. Okay, so that's the quiz. Even though it might say, hey, complete the square, right? But if you know you can factor it, if you know you can use the quadratic formula, right? Just get the right answer. Or you guys realize if the question is asking for solving an equation, would you simply just plug in an answer and see if it works? Do you guys understand what I'm saying? Yeah. For example, you see there are 4 options for solving equations like in letter A. One of the options looks like 3 plus radical 5, 3 minus radical 5. In TI-84, there's a quick, pretty easy way to just type in 3 plus radical 5. And what you do is just plug it in for x, right? Square it, minus 6 times x, right? Plus 4, see if there's going to be 0. And also, there's even fancy way to do that. So when we get a chance, I'll show you how that works out, right? My point is, if it's multiple choices, in SAT or in my quiz or even in my test, then you don't get any credits for showing the work. So there's no way I can see what you did. All I can tell is if you get it right answer or not. But in a test, there will be free response. And I can tell you that in our first test, which is probably September 21st, the earliest, right? Or maybe sometime that week. The first response will have questions saying that you have to solve this equation by completing a square. Then you have to figure it out how to show me the proper word for completing a square. But the reason why it's called free response is you do get a bit more freedom, even when it comes to showing the word for completing a square. If you're not sure if that's okay, like the certain way of doing a completing square, just talk to me in office hour or even show me in a class, right? As long as I tell you that, yeah, that's fine. Just a different way of writing it, then you're good to go. All right. But you do have to show me the general method, whatever they demand, right, in the FRQ question. Okay. Anyway, so let me demonstrate real quick with letter C. Again, for 2 reasons. First off, I do want you to get used to the routine of completing the square. The second reason is, let's see what complication that comes from potentially a imaginary solution. Okay. Just make sure that that's from the previous problem. All right, so letter C. I'm going to start with isolating just the quadratic and the linear term, right? Those are the only 2 things I need for completing a square. I'm going to get rid of that 5. You can subtract the 5 or think about moving it to the other side, right? But whatever you do, you're going to get a negative 5 on the other side. But the trick I told you about adding the square of half of the linear coefficient, as you can see from your work on the packet, will only work, right, for the trivial quadratic coefficient, but 2 in front of x is not trivial. So what you want to do is divide it out. So you have to do it across the board. Okay, that way the 2's cancel. You're left with x squared, right? And here again, cancel. You get negative x. I'll leave some space. You get negative 5/2. Now, can anyone tell us what could be the constant that I add to the left-hand side to complete the square for these two guys. If you still remember what we did. Right. Well, you have your work, right, for letter B. Sophia, right? Okay. How do you get 1/4? Mm-hmm. Okay, good. Thank you. Now, if you understand what she said about how she got the 1/4, great. If not so sure, as an instructor, I'm obligated to write down again, the way that works out in a consistent manner. So she got 1/4 by squaring -1/2. And how she got the -1/2? She noticed that the linear coefficient is -1. And I said, take the half of the linear coefficient. That's how you get -1/2. We always have to square it, then add it to these two terms. But she figured out it's just 1/4, right? Now, make sure that you also add the same thing on the other side, just to balance out the equation. Okay. Now, the next step is even more crucial to the whole process, because our goal is to complete a square. So now you have a perfect square trinomial right in front of you. You might not see it that way, but it will definitely factor the way you want. Right, so now, can anyone tell me how the left-hand side factors? Well, I don't mind to remind you that it has to be something, right, entirely to the second power, right, perfect square. But what goes into parentheses? Valeria. Thank you. Does everyone see it? No. All right. Now, this is the reason why I choose not to square it out, because I know that maybe sometimes people want to see exactly how it works out algebraically so they feel convinced. But I'm telling you a little trick. The trick is, if you have a trivial leading coefficient, you go grab that you have a trivial quadratic coefficient. That means you get to just go grab that linear coefficient and take the half of it. Okay. And then later on, it is the same number here, which is half of the linear coefficient that enters the perfect square form. Whatever that is, -1/2, right? Goes here. You want to convince yourself that's the case, take a look at what we did yesterday. After I divided the 9, what was the linear coefficient? -6/9. Now, how do I get half of -6/9? I mean, just multiply by 1/2, right? Now, of course, simplify it, or if you don't want to do it, go ahead and do 6 times 1, right? And 9 times 2, and it's going to be -1/3. Or you can even type it up in a TI-84. There's a way to change your answer into a fraction, right? If possible, then do that, right? Don't stress out in the test doing the fractions. Either way, I take the half of that linear coefficient, and I got -1/3, and see that it is the same number that enters the perfect square form. So there shouldn't be any extra thinking. Okay. But don't get me wrong. If you think that, well, if I only need half of the linear coefficient because I need to factor the left-hand side in a way that looks like a perfect square, why would I write down the square of the half of the linear coefficient? The reason is because you need the same thing on the other side to balance out the equation. Because you're not supposed to simply just do something like that without worrying about the other side of the equation, right? Simply put, make sure that you divide out the leading coefficient, then do the rooting, right? Taking a half of the leading coefficient, square it, add it to the both sides, and when it comes to factoring the left-hand side, right, the perfect square trinomial, put the parentheses down, put the square there, go with whatever variable you have, could be x, could be y, and just stick that number 1/2, -1/2 in it. It will be the same number that you see over here before you square that. Okay. Anyway, now the right-hand side works out as a pure number, right? Like I said, if you're okay with doing the fraction stuff by hand, you know, good for you. Or if I were you, I'll type it up in a calculator. Okay. But here, you know, I don't have a calculator with me. -5/2 plus square root of -1/2, 1/4, right? 5/2 is 10/4, right? So -10/4 plus 1/4. This is -9/4. Okay. So now you're looking at an equation that's ready to be square rooted. Now let's go ahead and recall the square root property, right? So taking a square root on both sides, you're getting x minus 1/2, right? And square root of -4/9, right? Please don't forget the plus or minus. Now, don't freak out if you see a negative number on a radical. You just have to exchange that negative sign for a imaginary unit I outside the radical, and it's multiplying the radical. From some experience, remember that we know how to simplify the radicals. So 9/4 happens to be a perfect square of 3/2. So this works out as positive or negative 3/2 I. Okay, so far so good, right? You guys okay with everything I go from factoring all the way to here? And you're pretty much done, right? So I have to just isolate the x. If x minus 1/2 is plus or minus 3/2 I, your final answer will be 1/2 plus or minus, oh, come on, 3/2 I. Okay, that's it for letter C. All right, any questions so far? Yes. Where did I come from? All right, so this is our conclusion from the complex number analysis. If the real number x is less than 0, then radical x can be written as radical of absolute value of x times the I. Okay. For example, radical of -2 is nothing but radical 2 times I. Right? You can even think of that as a way of writing a negative radicand, because it actually concerns people. Yeah, what do you mean by a square root of a negative number, right? Turns out it's not real anymore. It's a number, not real. But right now, we're not doing anything crazy about the I, right? It's just something you put, okay, yeah, I'll come to you in a second, yeah. Thank you. So to be honest, I do prefer you put the I, oops. You know, that's not even the way I like to write the I. Have you seen the I like this? Right? Yeah, people accuse me of writing the 2, right, with a dot on it. It's just how I learned, you know, how to write those letters. But anyway, so yeah, I prefer I in front. The reason is if I write the number in a sloppy way, I might accidentally write the radical a little bit too long, and I on the radical is still defined, but it will be way more complicated than you can think of. All right, so let's not confuse our readers, right? But either way, in a test, whichever you want to put it, right, front or back, left or right, doesn't matter. Oh yeah, question. Okay. Yeah. Please remember. All right. So don't freak out if you have a negative sign. Just trade it for an I outside the radical. All right. Any other questions about completing a square? Okay. And again, in a quiz, you don't have to do this as long as you figure out how to solve the equation, right? But in the test, be sure that you're able to show me something like that, or maybe your own way to complete a square, but you have to complete a square to solve the equation if they ask you to do so. All right, if you guys are good with the letter C, now it's the time to introduce the last method, right, which could be your ultimate method for solving quadratic equations in general. That'll be the quadratic formula. So I think that all of us, right, including myself, have thought about why we're still learning all that different method, factoring, right, square root property, completing square. I'm sure that no one's going to try the completing square if they don't have to. We have a formula, right, a universal formula that works for any, literally any quadratic equation. Now, of course, in our test, you might have to show your knowledge about some other method. In real life, well, nowadays it's even even more irrelevant, right? So no one's really going to solve equations, any kind of equations by hand. But there's some equations that are easy enough, right, to solve. And why would you use the quadratic formula, right? So something like x squared equals -2, right? I mean, you could move the 2 to the other side. So you're looking at x squared plus 2. Then you realize, oh, we have a 1 for the A, we have 0 for the B, and 2 for the C. Then shuffle everything into the quadratic formula, and you're going to get still some imaginary units, right? Imaginary solutions. But the thing is, do you see that it's ready to be taken square rooted, right? X is nothing but plus or minus square root of -2, right? And you know, you're not even wrong to just leave it like that. Because at least at this moment, to me, radical -2 or radical 2i is just only some kind of a cosmetic difference. Right? And you get the answer right away. Right? Therefore, if you look at the last part of the packet 1.5, I talked about like the most, let me see what it called it. The most efficient method, right, to use. So I wanted to be open to different methods and try finding the most efficient and most reliable way, right? That means in SAT, I don't think that you're going to try to solve equations using a standard method. And I doubt those equations about those quadratic equations in SAT are designed for you to use the quadratic formula. There are better, faster ways to do it. And that's what makes you stand out. Okay? And that's why usually you're expecting quadratic equations, but solving those equations in module 1. So pretty much I don't think there's much I have to tell you about quadratic formula. I will demonstrate maybe 1 or 2 problems. But the part that I do feel like I want to share with you, hopefully that opens up your mind about math, right, in general, or maybe just algebra. Let's say, how do we prove the quadratic formula? But you don't have to prove it. Just like you don't have to build, you know, a tool to use it. You can buy it, right? Do you ever have to prove the Pythagorean theorem? before you use it in geometry? No, you just know what it is, right? So don't get me wrong. Just because I try to show you how to prove it doesn't mean you have to know, the proof. But I hope that you can push yourself beyond the level of, things that you are comfortable with. And also, the good news is you will see that the way to prove the quadratic formula is nothing but doing a completing square, as long as you are open to do the same thing with those letters. Okay. Anyway, so take this as just a quick review, or see how confident you are with this method of completing a square. All right, so I'm going to start with a generic quadratic equation. The first step, as you saw in letter B and C on page 3, is to just keep the two terms that involving x, right? The quadratic and the linear, and get rid of that constant. Okay, so you're going to get negative c, right? And all I did was subtracting c on both sides, right? So I'm sure that that's okay for you guys. Now that little trick of adding half of I'll leave it there. Adding half of the linear constant to complete a square will not work out if you have a non-trivial quadratic coefficient. But a is not necessarily 1. It could be 1, but most likely could be something else. All I know is a is not 0. So just to be safe, let's get rid of the a. We cannot simply just ignore it. The proper way to get rid of it is to divide it out. We have to do that across the board. And the good news is a is not 0. Okay. So once you simplify every term, or at least that the first term, you're looking at x squared, right? Since a canceled. The second term is okay if I write it as b over a, but putting the x on the side. Is that okay for you guys? Okay. Because some people don't like, seeing that, but b is times multiplying with a. All right, I'm gonna have some space here to complete the square. It's negative c over a. All right, now it's the time to test how much you have got from the completing square drill, right, with the numbers. What do you think I should add to the left-hand side to complete the square for those two guys? Louis. Yes. Thank you. Okay. I do want to make sure that everybody sees it. So the trick was take the half of the linear coefficient, which is b over a. How do you take half of it? Well, you literally multiply it with a half. Right? Multiply b with a 1, a with a 2. Or if you want to think of it as a division, b over a divided by 2. You guys know what keep change flip is? Divided by the 2 is equivalent. You keep the numerator, right? But change the division into multiplication of the reciprocal. That's what I mean, keep change flip. Keep the numerator, right? Change the division into multiplication, flip this guy into its reciprocal, right? And that works out the same. So however you see it, it is b over 2a. Okay. Now you add the square of b over 2a, but make sure that you do the same thing on the other side. All right. So now, who can tell me now the trinomial on the left-hand side factors. You can look at the work for letter B or C, all right, and go with the pattern. Go. Oh, I thought you raised your hand. Sophia. Square, yes. All right, now, here's what I think. The reason why that not many people responded or feel like they don't want to tell me, it's not because you don't see it. It's just you're probably thinking, wait, is that a trick question? Because, you know, it's literally what you're supposed to do, right? As if they're numbers, right? But sometimes, you know, especially in algebra, if you don't see something, maybe try write down what you know, right? Because, I mean, unless you're super visual, you know, some people are like really, really visual. They what they call like photographic memory, right? Or something like that, right? They see things, they do integrals in their head. Most likely we're not, right? Write it down. You know, maybe you're right. You just never seriously thought about writing it down. Okay. Anyway, now on the right-hand side, that looks a little bit scary, right? But I'm sure that there's not much you can do, right? Well, at least that you can square both the numerator and denominator to get b squared over 4a squared, right? Do you guys remember when we had pure numbers, fractions on the right-hand side, we did try to work them out, right? Add and subtract, you know, finding denominators. Like I was trying to find out negative 5/2 is negative 10/4, right? Can we do something like that? So the question becomes, do you know how to add or subtract rational expressions? Well, do you remember how you did that? I'll give you a simple example. How did you add 1/2 and 1/3? Go ahead. All right, so you multiply both the numerator and denominator with the 3. And what about 1/3? Yes. And that way, the denominator is going to be the same, right? And 2 times 3 is 6. 6 turns out to be the least common multiple for 2 and 3, or in this case, we call it the least common denominator, right? And then you get 3. Well, let me over 6 plus 2 over 6. Yes, it looks silly to have fractions, you know, that wasn't simplified enough, but the beauty of it is they have the same denominator. You get to simply add up the numerator, right? In this case, we'll do the same thing. Instead of the simple numbers, we're looking at 2 denominators, a and a 4a squared. Think the same way. I figured that 2 times 3 is the least common multiple. What will be your educated guess for the least common multiple for a and a 4a squared? Yeah, go ahead. Go ahead. 4. Okay. Let's put down a 4. Any more? Go ahead. You want to include a squared? So 4 times a squared. What about the rest of the class? Do you think this is going to work? That means, is this a multiple of a? Or how do you see it? Well, let me write that as 4 times a times a. Right? Is this guy a multiple of a? Or is a fact of this guy? Yes. Just like 6 is written as 2 times 3. Is 2 a factor of 6? 3 is also a factor of 6. That means you see it literally. A is one of those numbers multiplying together with other things to give you 4a squared. That means A is a factor of 4a squared. That means 4a squared is a factor, is a multiple of A. Now, my question is 4a squared also a multiple of 4a squared? Yes, right? Any number is the multiple of itself. Well, a number is a factor of itself, right? And therefore, it works. All right, now we're going to use the least common multiple. All right, so I have x plus b over 2a squared, right? So I'm going to rewrite the first fraction, c over a, as c times, come on, 4a over a times 4a. So I'm multiplying both the numerator and denominator with the same number, like, you know, I did over there, right, on the board. But what makes me believe that 4a is a good idea to multiply the a with on the denominator? Okay, go ahead. You'll get squares, you get 4a squared, and that will get you the same denominator as the second term, right? Our goal is to get a common denominator. Okay, now I'll add that to b squared over 4a, b squared over 4a squared, right? And now you see that the denominator is 4a squared for both fractions. The numerator is negative 4ac for the first guy, and b squared, right, for the second guy. Now, I hope that you don't mind me putting the other way around. Let's just look pure here, right? So b squared minus 4ac. Okay? You guys with me? Now what do I do? My goal is to solve for x. Sophia. Yes, I'm ready to take the square root, right? So on the left-hand side, you get b, x plus b over 2a, right? The right-hand side, you get square root of b squared minus 4ac, right, over 4a squared, and never forget the plus or minus. Okay. Now, I mean, you guys notice that 4a squared is a perfect square. Why would you keep it on a radical? Right? We can simplify it. So if you don't mind, let me write it as the square root of that famous combination of the three letters, b squared minus 4ac, right? Remember that? Teacher called them the discriminant, right? Square root of 4a squared. All right, so you have the same left-hand side. Okay, so now, what about the square root of 4a squared? How can I simplify it? Square root of. Okay, so I mean, you could write it like that. Okay, thank you. So now here's one way to see it, right? You can split the radicand, that the radical hits the 4 and an a squared, but then you realize that radical 4 is 2, right? And radical of a squared is a, right? But the problem is it may not work out in general. You know, the catch is still plus or minus. So I hope you understand. When we're taking the square root of something squared, let's say 2 squared, you know, well, that's obviously 2, right? Because square root of 4 is 2. But what if you're getting square root of negative 2 squared? You go with the PEMDAS, right? Square of -2 is still 4. Radical 4 is still 2. But how come I didn't get -2? I thought I should get the same number. No, you're always getting a positive number. When the number is positive, before you square it, you get the same number back. If the number was negative, you get the opposite of it. Okay, that means, simply put, you put plus or minus, because you know what? If negative, you go with a negative sign. That way, negative, negative, make a positive. Anyway, long story short, you will get 2a out of the radical sign. Sorry. Over 2a, right? But again, you know, maybe someone noticed that, wait, how come that I'm supposed to get a plus or minus, right, out of the radical, and I still have that plus or minus from the original expression, right? Don't I have two pair of plus or minus signs? No. Because think about, what's the point of putting another plus or minus in the first place? I don't know what this number is going to work out as, either a positive number or a negative number. I just don't want to be open to both possibilities. So having excessive plus or minus sign doesn't get you anything other than plus or minus, right? And therefore, now you have everything looks just like what you're supposed to have. You just have to subtract off b minus 2a or b over 2a. So you're getting negative b over 2a plus or minus radical b squared minus 4ac over 2a. Then, of course, you know, you could combine the numerator as negative b plus or minus radical b squared minus 4ac over 2a. And that's the famous, you know, quadratic formula, right? So now, do we do that all the time? Of course not, because, you know, somebody did that for us, right? Whoever did that like a couple hundred years ago realized that, you know what, just save the work. Eventually, you're going to get this combination of letters. Whatever you can figure it out, what those coefficients are, go straight to the end. And that's why they call it a formula.